Hi, I'm Ibrahim Vinod. In this video, I'll describe the hardware experiments accompanying our paper, Decentralized Safe Multi-Agent Motion Planning for Drones under Uncertainty via Filtered Reinforcement Learning. We compare the proposed approach, decentralized safety filtering for drones, with our prior work that used centralized safety filtering. For comparison, we consider a multi-agent motion planning task that required navigating 6 drones to 2 targets in an environment with 7 obstacles. We set up the experiments using bit-basis classifiers and several existing hardware and software tools. We made the following observations from the experiments. First, both approaches successfully accomplished the task while respecting the safety constraints. Second, as compared to the centralized approach, the proposed decentralized approach requires less computational effort but took more time to complete the task. We now describe the motion planning task. We wish to navigate the drones on blue tiles to the lavender target and the drones on the red tiles to the yellow target. The drones all fly at the same height and must not hit each other nor hit the obstacles, the brown tubes, and must not exit the environment marked by the brown tubes on the ground. Both safety filters account for uncertainty in the agent dynamics as well as in the sensing of the obstacles and the agents. On the left, we show the experiment with the proposed approach, the decentralized safety filtering. Here, each agent computes its own corrections to the RL based motion plans to guarantee probabilistic safety. On the right, we show the experiments with our prior solution, the centralized safety filtering. Here, a centralized server computes the corrections to the RL based motion plans for all agents to guarantee probabilistic safety. Thank you for your attention.